Welcome. Today I am going to demonstrate how to effectively use interactive computer tasks, or ICTs, within your middle school and junior high classrooms. This toolkit will help teachers implement ICTs and align assessments with NAEP's innovative science assessments. As we progress towards computer-based testing in Montana, we need teachers to learn how to effectively use ICTs in their classrooms to better prepare students for these kinds of computer-based tests in the future. Within this toolkit, teachers will be taught how to use the ICTs in their classrooms to effectively provide students with skill sets that are beneficial to testing with computer-based assessments, especially on rigorous subject matter. Interactive computer tests, or ICTs, are computer-based labs that are designed to have students perform science labs through computer-based models. ICTs are designed for students to search and analyze information and conduct investigations through computer simulation. According to the nation's report card website, ICTs require students to solve scientific problems in a computer-based environment. These ICTs were designed to test students' abilities of conducting an experiment and gathering data without the logical constraints associated with the hands-on tasks. In addition to using these tasks as a part of a large-scale assessment, teachers can use them in their classrooms. There are many benefits to using simulations like these in the classroom. How do simulations support learning? Cosma and Johnston conceptualized 7 ways instructional technology can support learning. Here are 5 ways that can relate to computer environments like ICTs. Enabling active engagement in construction of knowledge. Simulations give students control in the exploration of scientific concepts and phenomena. This promotes active engagement and allows students to construct knowledge. Making available real-world situations. Simulations can allow students to investigate phenomena that would not be possible to experience in a classroom or laboratory. For example, simulations can allow students to participate in experiences with things that are too small, too large, too slow, too fast, too expensive, and too dangerous. Providing representations in multiple modalities. This opportunity to experience physical, chemical, or biological systems through multiple modalities can help students to create mental models that they can use to understand and work with science content. Facilitating collaborative activity among students. Students work in groups and can use a simulation to explain and describe their understandings to each other. This collaboration provides students key opportunities to participate in key practices of science. In seeing interconnections among concepts, simulations can also provide a unique opportunity to make connections between concepts clear and help students to engage in a more integrated view of science. 3 different sets of tasks were administered at grades 4, 8, and 12. Students' performance on hands-on and interactive computer tests indicated several key discoveries across grade levels. This interactive feature shows some examples of student skills across those grade levels. Key Discovery 1 at grade 4, students were successful on parts of the investigations that involved limited sets of data and making straightforward observations of that data. Key Discovery 2 at grade 8, students were challenged by parts of the investigations that contain more variables to manipulate or involve strategic decision-making to collect appropriate data. Key Discovery 3 at grade 12, the percentage of students who could select correct conclusions from an investigation was higher than those students who could select correct conclusions and also explain their results. I have included a brief explanation of each of the ICTs the website has to offer for each of the grade levels 4, 8, and 12. Each short task is approximately 20 minutes long, and at grade 4, Those are Here Comes the Sun and Cracking Concrete. Grade 8, Playground Soil and Bottling Honey. Grade 12, Starlight and Energy Transfer. Each extended task is approximately 40 minutes long. At grade 4, students complete Mystery Plants. At grade 8, Planning a Park. And at grade 12, the Phytoplankton Factor. A set of 3 computer-based labs have been designed for 6th through 8th grade classrooms. The first task, and the one we will walk through later in this presentation, is titled Bottling Honey. In this lab, students are asked to investigate flow rates of 4 liquids to determine the best temperatures for bottling honey. The second task for middle school students is titled Playground Soil. In this lab, students are asked to investigate attributes of 2 soil samples to determine the best site for building a playground. The third task for 6th through 8th grade students is titled Planning a Park. In this lab, students are asked to evaluate the impact of a planned recreation park on specific organisms. The released computer tasks can be found on the Nation's Report Card website. I have attached a link above to access this website. Once the Nation's Report Card website is up, scroll down to find the computer tasks located in the middle of the page. I am going to walk through the bottling honey test at the 6th through 8th grade level to show you some of the tasks the students are asked to do and how the site works. The first page of the bottling honey task asks the students to read some directions and some introduction information on what the lab is about and what it is asked of the students to do in the test. Each ICT will have an introduction for the students to provide them with some information before they begin the lab. Each ICT has a variety of question types the students need to complete. Some questions are multiple choice, while others may be a written explanation in the form of a short answer question, where students are asked to explain how they know and use data to support their answers. On each slide, students are asked to perform tasks to gain data. In this particular slide, students can adjust the temperatures of each liquid. After making those adjustments, students then click on the drop button to simulate the lab. Students can actually see the reaction take place. Students are able to adjust the liquid they want to gather data on for each lab. Each time the student asks for the ball to be dropped, data is gathered in the chart for them to record. Once the students click on the Done tab, they are automatically taken to a response page. On this response page, students are able to compare their results with the correct answers for each multiple question. Students are also able to see the percentage of 8th grade students in each response category in 2009. As students scroll down the response page, they can see what they put in as each short answer explanation as well. This response page also gives them a sample complete student's response. This is a complete answer that meets all of the scoring criteria. Under each sample complete student response, students and teachers are given a scoring guide. This allows students and/or the teachers to then score the answer that they had given for each short answer explanation. There are a few other areas of the website I would like to point out. On the left side of the web page, there are a couple of things you as a teacher should take a look at. First, there is a tab to take you to an in-depth investigation of 3 tasks. Bottling honey is one of those investigations. The Nation's Report Card website states that students demonstrate the ability to design experiments and gather appropriate data, but had more difficulty when required to explain their findings. I have attached 2 links below that will take you to see how selected student groups performed on the bottling honey test, and to see the scoring materials for it as well. Each number on the left can be clicked on to get a more in-depth information on how 8th grade students did in 2009. During the month of September, I had my current 8th grade students take the Bottling Honey ICT. Here are a few things that we had found out. Number 1, students found it was pretty easy to play around with the results during the computer test. This meant that they could change many of the variables without using lots of materials that are required in hands-on tasks. While taking the Bottling Honey test, students in my classroom worked within lab groups that consisted of 2 to 3 students. When the groups were finished, the only way I as the teacher could get their individual response pages was for them to print it off for me to grade. It would have been nice to be able to email these results directly and grade them electronically. The last area of the website I would like you to look at and walk through is the technical notes for the ICTs and hands-on tasks offered by the website. Some of the areas that are explained within the technical notes are the item percentage correct, student percentage correct, process analysis, treatment of missing responses, and interpreting results.